The TRAPPIST-1 system has captivated our minds since its discovery, not least because of its 7 planets, bearing a resemblance to our solar system. 3 of these 7 planets are in the habitable zone, sparking conversations about the potential for life in this system. Each year, scientists uncover more and more about each of these planets, leading us closer to a crystal clear understanding of this system. This video will be a journey through this system, with the information we have about it as of 2026. Before we talk about the planets, let's briefly get some context about the system as a whole. TRAPPIST-1 is the central star, which was discovered in 1999. It's what's known as a red dwarf, which is a family of stars which are much smaller and fainter than the Sun. TRAPPIST-1 in particular has a mass of only 9% and luminosity of just 0.06% of the Sun. These play an important role in the discussion of habitability, as we will see later in this video. TRAPPIST-1's 7 rocky planets were discovered between 2016 and 2017, revealing an extraordinary compact system. If we were to replace the Sun with TRAPPIST-1, the entire system would fit within the orbit of Mercury, with plenty of room to spare. And again, this plays a role in the discussion of habitability. Now getting into the planets, we start with TRAPPIST-1b, the closest one to the star. 1b is about 1.4 times more massive than the Earth, and has a surface gravity about 1.1 times stronger. Given its low albedo, up close, this planet would appear having a very dark color, perhaps similar to the Moon. It orbits around 1.7 million kilometers away from the star in just 36 hours. Being the innermost planet, it's not surprising that 1b is the hottest planet in the system, with a surface temperature of around 150 degrees Celsius. 1b was the first planet that the James Webb Space Telescope analyzed to try to understand its atmospheric composition. The results were published in 2023, suggesting that 1b likely does not have an atmosphere. An atmosphere is critical for thermal stability throughout the planet, and so the lack of it, coupled with the planet being tidally locked, means that 1b probably looks and feels just like planet Mercury. TRAPPIST-1c is the second planet out. It's about 1.3 times as massive as the Earth, and has a surface gravity 1.1 times stronger, very similar numbers to 1b. Its orbit is around 2.3 million kilometers from the star, taking around 58 hours to do so. It's slightly cooler, with a surface temperature around 107 degrees Celsius. It was previously thought that 1c had a thick atmosphere, therefore turning this planet into a very hot Venus-like world. However, results from the James Webb Space Telescope, released in 2023, hinted that this planet may not have an atmosphere at all. But such studies were unable to rule out the presence of a thick, oxygen-rich atmosphere. This is a remote possibility, however, and wouldn't indicate a biosignature, as there are several known abiotic mechanisms that could cause such a result. Continuing on, we get to TRAPPIST-1d, the third planet from the star. We've now reached the inner edge of the habitable zone, meaning temperatures are really going to start to cool off. 1d is the first planet we're encountering, which is actually less massive than the Earth, having only 40% of its mass. This puts it in between the mass of Mars and Earth. It orbits at a distance of about 3.3 million kilometers from the host star, taking 4 Earth days to complete one. Its orbit puts it at a position where its temperature is 13 degrees Celsius, although this was calculated assuming it has no atmosphere. And about that, results from Webb in 2025 suggested that again, the best fit to the data implies a bare rock planet. But the presence of some kind of atmosphere could not be fully ruled out, and is subject to future studies. We are now well into the habitable zone, and TRAPPIST-1e is perhaps the most promising candidate in the entire system for Earth-like characteristics. It has a mass around 70% of Earth, and a surface gravity around 80%. It orbits at a distance of 4.4 million kilometers, taking 6 Earth days to complete one. Again, assuming no atmosphere, 1e has a calculated temperature of -24 degrees Celsius. This may seem cold, but this is actually very similar to Earth's temperature if it didn't have an atmosphere. Like the other planets in the system, it's likely tidally locked. At its position, it receives only 60% of the light from its star that Earth receives from the Sun. Given just how close it orbits to the star, this speaks volumes about TRAPPIST-1's extremely low luminosity compared to the Sun. In terms of its atmosphere, this is where astronomers are not quite sure. Initial results from Webb were released in 2025, and they provided quite a few possibilities. The first is that 1e has no atmosphere at all, and is bare rock, like the other 3 planets probably are. The second is that the planet has a Venus-like, very thick atmosphere with high clouds, of which the composition is unknown. The third is perhaps the most interesting, that TRAPPIST-1e has a nitrogen-rich atmosphere, with possible trace amounts of methane. This would not necessarily serve as evidence of life, but rather it serves as a clue that there's something more going on with this planet than originally thought. As of the time of writing, the data is inconclusive about which of these possibilities are most likely, and more studies are currently ongoing with Webb to try to gain a better understanding of TRAPPIST-1e. Continuing to move into the outer parts of the system, we reach TRAPPIST-1f. It has a mass only 4% higher, and surface gravity of 95% of Earth's. It orbits at a distance of around 5.8 million kilometers, in just over 9 Earth days. Again, given TRAPPIST-1's low luminosity, things start to cool off considerably out here. Assuming no atmosphere, 1f has a temperature of -56 degrees Celsius, but this could be made warmer by the presence of an atmosphere. As of the time of writing, there have been no results released yet concerning any details about 1f's atmosphere, although theoretical simulations suggest that 1f could be a water world with a steamy atmosphere, based on what we know about its density and planetary formation. If there is an atmosphere here, and given the planet's tidally locked, conditions could be mild enough on the terminator line, that is, the line between the planet's day and night side. Further studies are needed to understand 1f's atmosphere, or lack thereof. We are now into the outer edge of the TRAPPIST-1 system, and Planet 1G is just barely inside the conservative habitable zone. It has a mass 30% higher than Earth's, and surface gravity 4% higher. It orbits at a distance of around 7 million kilometers from the star, taking just over 12 days to do so. Assuming no atmosphere, its temperature is calculated to be -76 degrees Celsius. Not much else is known about the physical characteristics of the planet, aside from theoretical simulations. Like 1f, it's possible that it is an ocean world with a water vapor atmosphere. If this is the case, then this would again warm the actual surface temperature to where life is possible, but further investigation is ongoing. Finally, we reached the outermost planet of this system, TRAPPIST-1H. It's quite small, having a mass only 30% that of Earth, and surface gravity only 60%. It takes around 18 days to complete its 9.3 million kilometer orbit from the star. And now is a good time to reiterate just how compact this system is. Planet Jupiter in our solar system has many moons, which orbit further from it than 1H orbits TRAPPIST-1. Assuming no atmosphere, 1H has a surface temperature of -102 degrees Celsius. The only way this planet could have liquid water would be the presence of a greenhouse atmosphere, or a subsurface ocean underneath the ice shell, as we see with the many icy moons in our solar system. We've explored all the confirmed planets of TRAPPIST-1, but the existence of an 8th planet, TRAPPIST-1I, was proposed in 2025 to explain some of the data from the Webb Space Telescope picked up in 2023. This proposed planet would be even further out than 1H, orbiting at 12 million kilometers away in 25 days. At the time of writing, this remains tentative, and it's possible that the detection was an artifact caused by the occultation of the known planets with each other. Further observations are needed to conclusively rule out or favor the existence of TRAPPIST-1I. Now the question still remains, is there a possibility of life on these planets? There's no conclusive answer to this question, but there's a growing population of scientists who believe the answer is no. The main reason for this skepticism lies in the star itself. Early on, we saw that TRAPPIST-1 is a very small and extremely faint star. We have also seen just how compact this system is. The fact is that for a star so faint as TRAPPIST-1, the habitable zone is naturally going to be very close to its surface. What this means, though, is that such planets are then going to be exposed to very high amounts of stellar radiation. This is especially true for this system. TRAPPIST-1 is well known to be a very highly active star, producing flares and star spots frequently. In fact, the reason why 1E's result was inconclusive was in large part due to the star's activity contaminating the data. As a result, it's possible and perhaps likely that all of these planets have had their atmospheres eroded by the star's activity long ago. This would essentially sterilize them and turn them all into barren, Mercury-like worlds. This is not just an issue for TRAPPIST-1, but for all red dwarf planetary systems. It's possible that red dwarfs are just not the right kind of star for a planet to be able to evolve life. At the end of the day, though, this is still an open question, and having a solid understanding of the rest of TRAPPIST-1's planets will provide evidence for or against the habitability of red dwarf systems. Regardless, this system is still fascinating, as only Kepler-90 is known to have more planets. It will surely be interesting to see where the data leads over the next few years.